All right, let's talk about inverse trigonometric functions. Okay, so with an inverse function, the inverse of a function is just the undo of the function, right? If we take a value, feed it into our function, we get a value out. An inverse function just takes the output and gives us back our input. All right, so in the case of a cosine function, we put in an angle, we feed it into cosine, we get a cosine value out. We get some value between -1 and 1 out of the cosine. Now, oftentimes we would like to be able to take the cosine value, feed it into a function, and get the angle back. We want to know what the angle was. And that would be, that function that we would use would be the inverse cosine. Okay? So, so we're introducing a new function, the cosine inverse, at least in this first example. But let's take a look at this example here. So in this example, we have a 6-meter long ladder leaning against a building. So there's my building and the ground, and then I have a 6-foot ladder, or 6-meter ladder leaning against the building. And the foot of the ladder is 3 meters from the base of the building. Okay, we're going to assume that this building makes a right angle with the ground. And we want to know, what's that angle? What's the angle that the ladder makes with the ground? This angle right here. So now remember, we don't know anything about right triangle trigonometry yet. So we don't know. This book starts with unit circle trigonometry. So what we have to do, if we're going to use just unit circle trigonometry, is look at scaling that angle, or that triangle, down to the size of a unit circle, okay? Because we're going to be using the unit circle. So if we do that, if we basically scale it down so the hypotenuse is 1, taking everything and dividing it by 6, right? It's just going to be this triangle on the unit circle is just going to be essentially a 1/6 scale model of this drawing I have over here on the left. So if I scale everything down by 1/6, then this is 1/2. And then you can see that the cosine of theta is equal to 1/2. All right. Now I want to know theta, and I'm going to use the inverse cosine to figure that out. So theta is equal to the cosine inverse of 1/2. All right. Now, if I use my unit circle, that's happens to be one of the key angles that I should know cosine values and sine values for. This is a key point on the unit circle because this is a 60-degree angle, all right, or pi over 3, right? And I know that the coordinates here are 1/2 and square root 3 over 2. Okay, so now I know that given that my cosine value was 1/2, I feed it into the cosine inverse, that will give me the angle, and the angle will be 60 degrees, or pi over 3 in radians. All right, so that's how the cosine inverse works. So let's take a look at these graphs down here. What I've done is graph the cosine of theta, y equals the cosine of theta, on Desmos actually, and that's the graph I got. I exported it, and the graph on the right is the same image. All I did was I flipped it vertically and horizontally so that I'm basically swapping the axes. So this axis over here is y, this axis is theta. I'm swapping the axes, so this axis over here is y and this is theta. Okay, that's all you're really doing. You're swapping the input and the output to create an inverse function. Now we have a little problem though with the inverse of a cosine if you just do it that way, right? So and the problem is that, okay, so let's say we want to know what the what angle corresponds to a cosine of 1/2. Well, here's a cosine of 1/2. Cosine is my y value on this first graph. And you can see, okay, well, must have been my 60-degree angle. That was between 0 and 2 pi, right? So that must have been my 60-degree angle. But I've got other angles it could have been. It could have been here. It could have been here. It could have been here. There's really an infinite number of angles that would give me a cosine of 1/2. But that's a problem, right? Because a function is has a very specific meaning in mathematics. A function has to have one output for every input. Okay, that's what a function is. And you might remember something called the vertical line test. You can't, if, here this cosine obviously passes the vertical line test. If I put any angle in, I get a unique cosine out. But the inverse, if I put a cosine value in, I have more than one angle that could possibly have that cosine value. So, but in cosine inverse is on your calculator too. When you put in a cosine value and take the cosine inverse of some number like 1/2, it only gives you one value. What value does it give you? So that's the key. One of the key things to understand about the cosine inverse is that it has a restricted range, right? The output is restricted. All right, it's not going to give you every angle that has that cosine value. It's going to give you an angle within a specific range. And then if it's outside of that range, you have to figure it out from there. And so we want to be able to put in any cosine value between -1 and 1. So we need to restrict it to a range that includes all of those cosine values. So here's what we do. We're just going to restrict the cosine inverse to the values in that range. Okay, so that allows me to put in any cosine value between -1 and 1 and get only one angle out. And that angle is always going to be between 0 and pi. It's always going to be between 0 and pi because we're restricting the range to between 0 and pi. All right, that's key. So let's summarize what we just said here. All right, I have a little box here we can summarize all this information. So the inverse cosine, which I should also mention is called the arc cosine. Arc cosine. And you can kind of see why. The notation for the inverse cosine has this -1, and it looks like an exponent, which can be confusing. So be careful with that because that is not an exponent. Okay, that is not an exponent. So so be careful. That's the inverse cosine. It's a totally different function than the cosine. It's not cosine to the -1 power. It is inverse cosine. So I think a lot of people like arc cosine because it doesn't have that confusing thing. And in fact, if you're going on to take Calc 2, the book that I use for Calc 2 uses exclusively arc cosine, not cosine inverse with this -1 superscript. Okay, so it's good to know both. Okay, so anyway, the inverse cosine, which is also the arc cosine, we define the inverse cosine to be the angle. So the output of an inverse cosine is the angle, and the angle is always going to be between 0 and pi because we're restricting the range. All right, and so this is just restating what we just said. Theta is equal to cosine inverse provided that y equals cosine of theta and the theta is between 0 and pi. Okay, just emphasizing the range restriction. All right, the domain is the input. The domain is always between -1 and 1. Okay, that's the input to the inverse cosine. We're putting in a cosine value, and cosine can be between -1 and 1. We're getting out an angle, right? And the angle that we're going to get out of the inverse cosine is always between 0 and pi. Okay, that's the key. That's the key thing to remember about cosine. Is it's not going to give you every angle that has that cosine. It's going to give you an angle that's within that range. And again, I want to emphasize that this is not this -1 looks like an exponent, but it is not. It is not. It is not an exponent. All right. So if we want to designate an exponent, we had to put parentheses around the cosine And in this case, the second case down here, it is an exponent. But when we write this -1 superscript beside the cosine, it is not an exponent. It's the inverse cosine. So the cosine inverse of 0 is the angle, right? If I draw the unit circle, it's an angle that has a cosine of 0 that is between 0 and pi. So we're restricting ourselves to this top half. Let me kind of draw it in red. We're restricting us to this top half, right? This is an angle of 0. This is an angle of pi. Right? We're restricted to the top half of the unit circle, and we want to know what angle has a cosine of 0, right? And that's going to be here, right? Because cosine is the x value. So the cosine inverse of 0 is pi over 2, and that's because the cosine of pi over 2 is equal to 0. Okay? Now, this other thing down here, this is a different animal. This is a cosine of 0 to the -1 power. Okay, so this is 1 over cosine of 0. Okay? There's a big difference. This is a cosine. This is a totally different function. And we're taking it to the -1 power. Okay, and so here we would get 1 over the cosine of 0. The cosine of 0 is 1. So this is equal to 1. So just make sure you remember that this -1 superscript, when it's written right next to the cosine like that, means it's a cosine inverse. All right, and if you do want the power of a cosine, you have to put parentheses around it if you want cosine to the -1 power, if that's what you actually mean. Okay, so we're going to do some practice with that in the next example, and I'll meet you in the next video.